This is a special example involving negative area. Okay, let's demonstrate how to consider negative areas. Given the dimensions of the following section, find the moment of inertia about the horizontal axis. So this is not a practical shape of beam, but we're just doing some exercise like considering how to determine the moment of inertia and determining the centroid. Right. So here we have this shape, and we have cut it into 3 sub-areas. As shown here, we have the first sub-area that is a triangle, second sub-area that is a rectangle, and the third sub-area that is a circle. Okay. So here we set the y values. We're determining y bar. We're determining y bar from bottom. Okay, it could be somewhere here. So our first task is to determining y bar. Okay, then you can see that we have the centroid of this sub area 1. Then you can define a y1, a sub area 2. You can determine a y2, and y2 equals y3. Okay, since their centroids are overlapping together. Okay, so based on this analysis, let's try to find out the centroid. First step, centroid, we're determining y bar. Okay, so let's start from a table. We have area 1, area 2, area 3. Right. For each of them, we're determining area, their y values, and then ai, yi. Right. So for area 1, what is the area? The subsection 1, what is the area? A1. A1 would be, bottom is A, height is C, right? This is half AC. Right? So A is 120, C is 60 over 2. That will be 3,600. Right? For a subsection 2, A2, it's just A times B. Right? A times B. A times B. That is 120 times 140. That is 1,600. Area 3. Area 3 would be a circle. This is a pi over 4 d square, and d is 80. Right. So here would be 5,027. However, this circle is a hole. Okay, nothing. There's no material here. So this will be denoted as a negative area. Okay, this is a negative area since you are just reducing this piece of material from this original piece of material. Okay, this is a negative area. So how about the y values? So the y1, as shown here, the y1 will be A, will be B plus C over 3. Right? So B is 140. 140 plus 20, that will be 160. And y2 and y3 are the same, and they're just a half B. Right? It's a B over 2 would be 70 here. Okay, so now we can calculate AIYI. So AIYI is 3,600 times 160, and here will be 16,800 times 70. And then here we get a negative negative 5027 times 70. Okay, so using these numbers, we can calculate that y bar equals sum ai yi over sum ai. Okay, you just get this value here, and then you can get the results. Okay, it will be 91.08 millimeter. Then we can calculate the Ix. Second step, we're calculating the Ix. This will be sum IC plus AIDI square. Right? The table area 1, area 2, area 3. Okay. Then we have AI, DI, and then we'll calculate ICI. Okay. AI has been here, we have calculated. $3,600, 16,800. Here is a 5027. Again, this is a negative area. Right? So the DI will be y bar minus yi. Right? So our y bar has been determined to be 91.08. 91.08 minus y1 is 160. So it will be 68.92. And the D2 will be y bar minus y2. So absolute values will be 21.08. Here also 21.08. And ICI. ICI, what is IC1? Area 1. That is a triangle. Okay. For the triangle, from our table, you can find how to calculate its I value. Okay, this will be AC cube over 36. Okay, what is the value? Okay, then for this area 2 will be just a B cube, right? AB cube over 12. What is the value? And for the circle, it will be pi over 64, d to the fourth. What is the value? Okay, I will skip these calculations. Okay, I will just give you the results. I give you the results. Okay, you just do exercise like using this equation, how to use this equation to calculate the overall Ix. Okay. Just keep in mind that for this area 3, it is negative. Okay, you need to deduce this material, this values from the sum of the previous two. Okay, so here the result will be 48.48 million millimeter to the fourth. Okay, do your own exercise. Try to get the result and let me know if my calculation is wrong.